And this is the Algebra 2 quick review, and this is 30, 60, 90 triangle. So how do you start? With an equilateral triangle. And split it right down the middle. Right? Split it right down the middle. That's going to give you a 60-degree angle bottom left, 90-degree angle bottom right, and therefore then this top angle has to be 30 degrees. Okay, now what are the value of the sides? So for the pattern, this side right here is half of this side right there. And I don't want to use fractions. So if I call this 2, then that's going to be 1. And by using the Pythagorean theorem, I can find this side, right? The square root of the hypotenuse squared minus the side squared. So the square root of 2 squared minus 1 squared is the square root of 3, and most like to have a 1 in front of that. Okay, so there's my pattern. And from this I can figure everything else out. So just to quickly go through a couple possibilities, if this was a 4, then that would be 4 times the square root of 2, and this would be twice the 4, or 8. Hopefully that makes sense. Okay? So, and you can do this in numbers of ways. If this were an 11 times the square root of 3, then this has to be an 11, and that has to be a 22, right? And then maybe something like this. If this is square root of 3 over 5, this would have to be 1/5. And what's 2 times 1/5? 2/5. Okay? Get the idea? We can do everything out of that. All right, also, because we have the pattern, we can get the exact values for all the trig functions, all of them for 30 and 60 degree angles. So let me just do a couple for you. The sine of 60 degrees. Okay, that's going to be the opposite of 60, which is square root of 3, right? Opposite of 60 is the square root of 3 divided by the hypotenuse of 2. There's your exact value for the sine of 60, square root of 3 over 2. How about if they want the cotangent of 30 degrees? Okay, cotangent is the adjacent over the opposite. So the adjacent is square root of 3, and the opposite is 1. So that'd be square root of 3. And you can do that for all 6 trig functions for both 60 and 30 degrees. Okay, let's do a couple with triangles here. So what if you're given a triangle like this? Well, you have to understand then that this is 4 times the square root of 3. So the value of this has to be 4. And the value of this has to be 8. No figuring, I just simply know the pattern. How about this scenario? How about if we're given a triangle like this? Okay, well, again, it's spun, but you have to understand that the 14/5 corresponds to the 2, right? And the x is going to correspond to the 1, so it's half of the 2. So what's half of 14/5? 14/10. All right, and I can reduce that to 7/5. Now, what is this side? The x, or the 1, times the square root of 3, so 7/5 times the square root of 3, or 7 times the square root of 3 over 5, right? Hey, not hard. Fractions as hard as they can get, and that still wasn't hard. All right, again, what if they give you something like this, and now where the square root of 3 normally is, you have square root of 6. Again, I think the easiest way to do these is a proportion. There is a shortcut. But let's say I'm always going to go for the side that's 1 first. So let's go for y. Y over the square root of 6. Now I'll use the pattern. And what goes where the y goes? 1. And what goes where the pattern goes? Where the square root of 6 is and the pattern is square root of 3. Okay, solve this. Multiply both sides by the square root of 6 over 1. You can either rationalize or simplify. And we actually, in this case, get the square root of 2. All right, so the value of that is the square root of 2. So what would the n be? Twice times the square root of 2. And there we go, we got them all. All right, 30, 60, 90 triangles. Real important because you can get all the trig ratios, but then also you can figure out other 30, 60, 90 triangles.